This is an incredible piece of engineering and construction. But when you see the pictures and the videos, it's difficult to get a sense of scale. So let's fix that. Welcome to my channel. It's me, and today we are going to take a journey back more than 4,600 years ago. We are going to go back before electricity, before iron, and before written history as we know it. Because if you want to hear a lot of people talking about ancient civilizations, it's usually Greek, Roman, Egyptian, and then maybe Mayan. We're going to travel to Egypt, and we're going to talk about the construction of the Great Pyramid of Giza. When I went to see it, I walked around in awe. I had never seen so many people congregated in one place in my life. There were lines stretching for hours to take the few cable cars that would take you to the top. On top of the plateau where there are 3 pyramids, there are also camels and people selling souvenirs, all kind of crammed together. At the bottom, the area itself is surrounded by a ring road, which makes it hard to get close to the actual site. In fact, you can't really get up close and personal with the only remaining ancient wonder of the world. You can see it, but you cannot touch it. I stood there, and I watched a guy walk across the base of the pyramid, and it gave me a sense of scale. I realized that 2.3 million limestone blocks and granite blocks, each weighing up to 50 tons, were moved one at a time and placed precisely where they belong without the aid of any modern equipment. This happened over a span of approximately 20 to 30 years during the reign of Pharaoh Khufu between 2580 and 2560 BC, and to this day, the Great Pyramid of Giza remains the tallest man-made structure on Earth for nearly 4,000 years. The Great Pyramid faces almost exactly true north. Its sides align within 3 arc minutes of being perpendicular to the cardinal directions. The base of the pyramid is a regular tetrachedron, a 14-sided polygon with 14 equal sides and 14 equal interior angles. Each side of the Great Pyramid is 756 feet, or 230 meters long. Height of the pyramid is 481 feet, or 146 meters tall, making its volume 2.58 billion cubic feet, or 73 million cubic meters. The angle of the slope of the pyramid is 51 degrees, 51 minutes. The height of the largest block in the lower courses is 9.8 feet, or 3 meters. The estimated weight of the largest block in the lowest course is 40 to 50 tons. So how was this done? How do you build a pyramid with such accuracy? Well, that's the million-dollar question, literally. There are dozens of books and thousands of papers written about this very topic, and it's been a hot debate for hundreds of years. As a kid, I remember seeing a diagram of 2 ramps that stretched from the ground to the top of the pyramid, and thought that this must have been how the Egyptians moved the huge blocks. Well, turns out I wasn't far off. This idea is called the wet sand ramp theory, because the ramps were probably covered with wet sand to help pull the blocks up the ramp. The ramp theory is one of the more popular ideas on how the pyramids were built. However, it does have its problems. In order for this to work, there would need to be large teams of workers, probably around 4,000. They would need to move the huge blocks from the quarry, drag them to the building site, and then start the process of moving the blocks up the ramp. There would need to be a central depot where all of the stones were brought before they were moved up the ramp. This would be a logistical nightmare. The idea of the internal ramp came later and is much more elegant. The internal ramp runs through the middle of the pyramid. Blocks are pulled up the ramp and then put into place. This requires a much smaller workforce, around 1,000 workers. This means that the internal ramp is much more energy efficient. Another advantage of the internal ramp is that it doesn't require a large flat area at the bottom of the pyramid. These theories work well if you assume that the stones were all quarried away from the pyramid building site. However, recent studies suggest that most of the limestone blocks were quarried closer to the building site. If this is correct, then a ramp becomes even more plausible. A ramp would also explain why no complete limestone blocks were found inside the pyramid. If you look at the bottom layer, or the course, you will notice that the blocks are T-shaped. These T-shaped blocks are called a foundation course. They are used to stabilize the weight of the upper courses. Without these blocks, the higher courses would not be stable enough to hold the enormous weight. There are 4 main theories on how the pyramids were constructed, categorized by the level of technology required. Theory 1 is the external ramp theory. This is the theory that I described earlier. The theory suggests that the blocks will hold up one or more external ramps. The ramp theory is the simplest of the 4 theories. It requires no special tools or techniques. It also does not require any advanced mathematics or astronomy. It simply requires a lot of manpower and some simple tools such as levers and rollers. The ramp theory is also consistent with evidence found at the pyramids. For example, there are marks on some of the limestone blocks, which could have been used as handles for hauling the blocks. Theory No. 2 is the internal ramp theory. This is similar to the external ramp theory, except that the ramp is built inside the pyramid. This theory is more complex than the external ramp theory, because it requires more advanced techniques. It also requires more advanced mathematics and astronomy. The internal ramp theory is also more labor-intensive, because it requires more workers. Theory 3 is the counterweight theory. This theory is based on the principle of balance. The idea is that blocks were hauled up a central shaft and then balanced in place using counterweights. This theory is the most complex of the four theories. It requires the most advanced tools, techniques, mathematics and astronomy. The counterweight theory is also the least likely of the four theories, because it would have been extremely dangerous. Theory 4 is the lever theory. This theory is based on the principle of leverage. The idea is that blocks were placed in position using a system of levers. This theory is also very complex. It requires advanced tools and techniques, as well as advanced mathematics and astronomy. The key to solving this mystery may lie in a combination of all of these theories. Regardless of the method used, it's clear that the ancient Egyptians were highly skilled engineers and mathematicians. They had a deep understanding of geometry and astronomy, and they were able to use this knowledge to build structures that still stand today. The construction of the pyramids is a testament to the human spirit of exploration and discovery. It is a reminder that we are capable of great things when we work together. I hope you enjoyed this episode of Engineering Explained. If you did, please subscribe and watch more. If you have a favorite construction project or piece of engineering that you would like to see featured on Engineering Explained, send me a message and tell me about it. I'd love to hear from you. Thanks for watching.